All right, geometry. This is going to be for lesson 10.5, segment lengths and circles. The homework is actually not 33, it's 32. That was my mistake. Okay, 32 goes with this assignment. So we're just going to talk about what happens now with all these segment lengths. Okay, so let's take a look at some of these examples. The first one is going to be what happens when two chords intersect each other. So when two chords intersect each other, there is a mathematical property that happens, and basically it's this. This segment times this segment, if you multiply those two together, so CE times ED, which is right here, CE times ED, that's going to equal to the product of this segment multiplied by that segment, okay? So this segment times this segment is equal to this segment times this segment. So as an example, I'll just put some numbers up here. If this is 2, and that's 9, again, I'm just making up numbers, and this is, let's just say that's 6, I can figure out what this missing segment is right here, because 2 times 9 is 18, 6 times 3 has to be 18, so that would have to be 3. Okay, so this times this is equal to this times this. So let's take a look at these two examples here. My suggestion is to pause the video right now and get these two answers done, just for A and B. Pause the video. Okay, so for the first example here, for question A, you should get 18 times x is equal to 108, so x is 6. And in this example right here, you should have 10x is equal to 40, so x is equal to 4. So let's take a look at what happens now when we have secants. Okay, so let's see, two secant segments. If two secant segments share the same endpoint outside the circle, then the product of the length of one secant segment and the length of its external segment equals the product of the length of the other secant segment and the length of its external segment. Way too wordy. Let's take a look. So we have two secants from the same external point. And this is where a lot of people make a mistake, so be careful. Basically what it's saying is the external part times the entire secant, okay, that's E to B, is equal to the external part times the entire secant, okay? So it's EA times EB is equal to EC times ED. And a lot of people do this wrong. A lot of people like to do the outside piece times the inside piece is equal to the outside piece times the inside piece. That is wrong. Don't do that. It's the outside piece times the entire secant is equal to the outside piece times the entire secant. So let's take a look at these two examples right here. Let's do this one together. So I got to find the value of x. So let's take a look at this top secant segment right here. That is going to be 11 times 21. Okay, not 11 times 10. It's 11 times 21. It's the outside piece times the entire segment is equal to the outside piece times the entire segment. Now, the entire segment is going to be 12 plus x, right? That's the entire secant segment. I'll call it x plus 12. All right, so let's go ahead and solve this. Let me grab my calculator here. So 21 times 11 is 231 is equal to 12x plus 144. Subtract 144 the other way. So you get 12x is equal to 87. And you could just leave that as x is equal to 87 over 12. That does reduce. 3 goes into both of those. So it's going to be, what, 29 over 4. All right, so x is 29 over 4. Go ahead and try the next one, please. Pause the video. All right, so you should get x equals 18. All right, so the first secant segment is the outside piece is 12. The entire secant is 12 plus x. So 12 times the quantity of 12 plus x is equal to 15 times 24. Again, not 15 times 9, 15 times 24, because the entire secant is 15 and 9 is 24 units long. And when you solve that, distribute, you're going to get 144 plus 12x equals 360. 12x is 216, divided by 12, and x is 18. Turn the page. Okay, and now let's take a look at the other scenario. The other scenario is when you have a secant and a tangent. Okay, so over here, right, we have one is a secant, one is a tangent. So when you have a secant and a tangent, you're going to do the same thing as what we did before with the secant, is going to be EC times ED. It's the outside piece times the entire secant. Now the tangent should be common sense. A tangent is only this segment right here. So the only thing you can multiply a tangent by is by itself, right? Because you need to multiply two things here. This times this is two things multiplied. So this is going to be the tangent times itself, okay? So whenever you have a tangent, it's always going to be the tangent times itself is equal to EC times ED. So let's take a look at this example over here. So we got to find the value of x. So I have a tangent with a secant. So the tangent, you're going to have to multiply it by itself. So you're going to say 3 squared is equal to, now one more time, it's going to be the outside segment times the entire secant segment. Okay, so the outside segment is x, the entire secant segment is x plus 2. So I now have 9 is equal to x squared plus 2x. Subtract 9 the other way, x squared plus 2x minus 9 equals 0. Oops, and equals 0 there twice. X squared plus 2x minus 9 equals 0. And that is definitely not factorable, so we're going to go ahead and do the quadratic formula for that one. So x equal to opposite b. You can just pause the video right now probably and get this done. All right, so working through the quadratic formula, you're going to get x is equal to negative 2 plus or minus the square root of 2 squared minus 4 times 1 times negative 9 over 2. So that's going to be x is negative 2 plus or minus root 40 over 2, which means x is equal to negative 2 plus or minus 2 root 10 over 2. Try and go reduce that because 2 goes into all three of these numbers. So you're going to get x is equal to negative 1 plus or minus root 10. But the negative is going to get rejected. Okay, you can't negative 1 minus root 10. We just go to the calculator here. Negative 1 minus root 10 is negative 4.16. And this segment right here can't be negative. This segment right here can't be negative 4.16. That doesn't make sense. So we're going to reject the negative. So negative 1 plus root 10 is the only answer. Go ahead and try B and pause the video and see what you get. All right, so for this last example here, you have a tangent. So tangent squared, 10 squared is 100, is equal to the outside segment times the entire segment. So that's going to be x times the quantity of x plus 15. So you now have 100 is equal to x squared plus 15x. When you bring the 100 to the opposite side, you get x squared plus 15x minus 100 equals 0. That is factorable. That's x plus 20, x minus 5. X plus 20, x minus 5 factors. Or you do the quadratic formula. So that means x is negative 20 and x is 5. But x cannot be negative 20 because that means you're having a negative 20 as the outside segment piece. That doesn't make sense. So the only answer is x equals 5. We're going to reject the negative 20. Go ahead and do the last example. This is a review. We did this question, well, it seems like forever ago. This was on lesson 10.1 on page 67 in our notebook. So if you want to go backtrack to page 67 in our notebook, we did one just like this. Actually, we did 2 of them just like that. So go ahead, research that, pause the video, and see what you get. Okay, so here is the picture. You're standing 18 feet from the circular display case. The distance from you to a point of tangency is 32 feet. And remember, the tangent and the radius are always perpendicular. So we have a right triangle drawn here. So Pythagorean theorem says 32 squared plus r squared is equal to, now this segment right here is 18 plus r squared. Now this is not the same as what we were doing over here because this is not a secant. Okay, this is not a secant. Okay, so we are not doing like the outside piece times the full length, that kind of stuff. Okay, that's what we did up there, not here. So let's go ahead and solve this. 32 squared is 1,024 plus r squared is equal to, so this is 18 plus r squared. I'm just going to rewrite that as r plus 18 squared because we always like to have in a binomial the variable first. So remember, this has to be FOILed, right? This is FOILed. So when you FOIL that, that's going to be r squared plus 36r plus 324. And now you just, well, this is going to be actually, this is an easier one because if I subtract r squared to the opposite side, the r squareds are going to cancel. So you now have 1,024 is equal to 36r plus 324. Subtract 324 the opposite way. This one worked out pretty nice here. So you now have 36R is equal to 700. And when you divide by 36, R is going to equal about 19.4 feet. It did say estimate, right? So we can round to the nearest tenth or so. You can be right around 19.4 feet. So that's today's lesson. Do the homework, please.